On to problem number 2 from the 2022 FRQ set number 1. We're going to jump right into this one. It's another problem that was pretty challenging. The overall score was about the same as the first FRQ, but let's see what it's got in store for us. So looking at it, first off, I'm seeing something going down a hill and then a collision. So I think that's all it's telling us right now, but cart 1 mass M2 is greater than M1. So M2 is the bigger car and the heavier car is at the bottom at rest. Time 0, cart 1 is released and travels down the incline and smoothly transitions. Vertical distance H. At time TC, cart 1 reaches the bottom of the incline as immediately collides with and sticks to cart 2. So it's a sticky collision. Okay, so we got, I'm going to guess conservation of energy downhill, sticky collision for the collision. Frictional and rotational effects are negligible. Beautiful. I love it. Thank you, College Board, for that. During the collision, the impulse on cart 1 from cart 2 greater than, less than, or equal to the magnitude of the impulse from cart 2 on cart 1. This is a gut instinct sort of thing for some of you probably, but if I go over to the momentum stuff, where's the momentum stuff here? I'm wasting time. But the impulse is the change in momentum. They're equivalent to each other. And in order for momentum to be conserved, whatever one gains and the other has to lose. So in this case, it should be equal. The impulses are equal. So an explanation for that, cons of mode dictates it. We also have that Newton's third law, which you could then fill in later and say that they're both feeling the same force in opposite direction. So the impulse would be this equal in magnitude between them because it's for the same time. All right, let's go on to part B. On the following axes, draw graphs of the magnitude and momentum of each cart as a function of time before and after TC, the time when they collide. So they're drawing this quick is not going to be easy. We have to really think through what's happening with the cars. But I think this is a standalone. So if you were to skip this, it's not going to harm you doing the rest of the problem. But let's go ahead and maybe take a look at it real quick here in terms of trying to set something up. TC is when the collision happens. So car number 1 is going down a ramp. It's got a constant acceleration on the ramp. It should just increase in velocity, increase in momentum like this. And then when it hits, it should decrease, but it's not going to stop. It's going to drop down somehow immediately, and then it's going to continue on at that speed. Spoiler alert, I already know how to solve this problem, but something like that, if you were to sketch it, would be good. For cart 2, you should definitely say that it has nothing in the beginning and then it jumps up to something. These are the way the graphs are supposed to look, but if you were to come up with something like that, you'd be fine. Otherwise, you skip it. It's not connected to the rest of the parts. Show that the velocity via the 2-cart system after the collision is given by this. Well, we know that we haven't had to calculate anything for this yet, but for cart 1, it would be a conservation of energy problem to start off. And then the collision would be a conservation of momentum, which would be sticky. So I would just kind of write in some equations for this right off the bat. I would say that UG for 1 turns into its kinetic energy, and M1 times G times H. I'm saying it's not G1, it's just M1, which would then be equal to 1/2 M1 times its velocity squared. So we'd have to, it's going to be its velocity when it hits the bottom of the ramp. And then the collision, whatever velocity we get here is going to be the starting velocity. We'd have M1 times that, call it VF for now, plus 0, equals M1 plus M2 times some new velocity V. And then it's a whole bunch of math after that. But writing this down, I think, is a good start to set it up for getting points later. D, oh boy. So they give us a graph. I immediately see this draw best fit line. Sweet, no problem, I can handle that. But they say they determine cart 1 is, they measure it to be 0.25. The cart 2 is unknown. They perform several experiments where they graph stuff. Basically, they graph this relationship that they already told us should exist, and they want us to draw a best fit line and use the best fit line to calculate the mass of the cart. This should be a gimme. you draw a line, all right, give me point. Graph's already labeled. And then 2, use the best fit line to calculate something. Slope, baby. I want the slope. I'm gonna have to find it at some point. So my rise over my run is gonna be some sort of delta V over some delta of square root of H. But it's a rise over 1. I mean, we could calculate it with all the numbers, but we're already out of time. Let's see what else is in the problem that we could try to throw some attempts at here. Oops, didn't mean to do that. Part E. Oh, there's another one of those justify your answer things. So they determine that cart 2 is less than what was determined in part D. So whatever you get here, it's a smaller number. To explain this discrepancy, one of the students proposes that the mass of cart 1 was incorrectly measured at the beginning. The students think, what should it be? Well, if they turns out that one's less than the other, my guess is that the M1 would have to be smaller than what they thought it was as well. I'm not sure, but yeah, we'll go to that. We'll think about that one later. We tried to put some stuff down here, so let's go ahead and see what we got for the rubric. Go and slide it over, since I've already got it up from the previous FRQ. First off, this problem was 7.12 average with a standard deviation of 3.75. So yeah, a lot of people didn't score so hot on it. Seem to say that a lot for these AP Physics CFRQs. All right, part A, for selecting equal to, we get a point. Sweet. So with an attempt at a relevant justification. So even if you're wrong, just because you put equal to and you tried, you know what? Gold star for you. There we go, 1 point. For correct justification, Newton's third law says equal. Okay, so that was the appropriate one. Conservation of momentum maybe wouldn't have been the best way. Could be okay, but they just used Newton's third law. So 2 for 2, looking good. Stop the problem right there and score it. For correctly drawing the momentum for carts 1 and 2 for the time interval 0 to TC, linear increasing for cart 1 and 0 for cart 2. So if you just did this and this, that would be worth 1 point. Linear increasing doesn't have to go to someplace special. For drawing a horizontal line for cart 1 when T is greater than TC, that is smaller in magnitude than the momentum of cart 1 at time TC. So yeah, it's got to drop. So for drawing a horizontal line having a drop, you get a point. For drawing a horizontal line for cart 2 is greater in magnitude than the momentum of cart 1 after. So just having it higher would be worth 1 point. And then changes of momentum that are equal is worth a point. So you can get a couple of points here just by kind of relatively showing things. 4 points total is correct. My graph is almost exactly what they have. I just showed that the decrease in momentum for one is the increase in the other. That's what they would get you the 4th point. But let's be honest, maybe 1, maybe 2 points on average for someone just trying to go through that quickly. Part C. Oh, part C is worth, that's a lot. Oh my God, that's a lot of math. 3 points. 1 point for using conservation of energy to find the speed of cart C at the bottom of the incline, or for correct substitution of acceleration and displacement in a kinematics function. 1 point for using conservation of momentum to find the speed of the 2 cart system after the collision, for combining correct equations from above. Interesting. So I'm not sure how they would exactly score this. Would this be enough to count as 1 point? I set it up. I didn't actually solve it. But I guess if I solved this to figure out velocity, then it'd be a point. So I don't know. That's a tough one. So the same thing here, that this is a hypothetical. It's like I set up the equation, but I didn't actually solve it for V. So I'm not sure. It's combining these two things together, plugging one into the other is worth another point. So this over here is just showing what the answer would be, proving this thing, which you already know what it's supposed to be. So maybe that's why they're a little stingy with the points. So we'll put those as a maybe. And then part D, give me some graph points. Give me some graph points. For drawing an appropriate best fit line, perfect. I'm giving myself a 1 for that. Considering I just scribbled it really quickly, I know I would do the line correctly. I would do it the right way in reality. I'd use a straight edge for it. So I'm gonna give myself a point for that. For calculating the slope using 2 points on the best fit line. So if you actually continued this and got a number, then you'd get 1 point for that. For correctly relating the slope of the best fit line to the mass of the cart 2, I think that's this whole thing, like setting it equal to that formula, which we did not do. So if we'd have time to finish that, we'd be able to get the point there. And then this thing, I was saying that, well, we didn't really answer, but saying that M would have to be smaller as well. Yeah, I don't know. If one mass ends up being smaller than it was supposed to be, then the other one probably is as well. That's how the collisions work. Otherwise, everything would go all askew. But let's go ahead and total up our probables and hypotheticals here. So 1, 2, that could have been a 3 and a 4. I'm going to say that this one up here is a hypothetical. So 3 possibles, keeping this count on my finger, 1, 2, 3, 4, 5, 6. So that's 6 points with a potential, if you just, guessed okay on some of this stuff, or this was okay, of 9, which is actually pretty dang good. So that's problem FRQ number 2. I'm not going through the full solution here. You got the whole guide that you can look at later. On number 3.